It's
right.
also a lot of information to get absorbed in what, 6 weeks?
Yeah, I mean, it's bad enough. It's already 6 weeks. And then on top of that, we missed what, at least 3 or 4 days? So we lost almost a week, pretty much, with all the days off and the unforeseen events and the holidays and everything. Because we had Juneteenth, 4th of July, we missed today, and we missed a day last week. We lost a whole week. Yeah. But it's all right though, because what do we do in bad situations? We adjust our fighting position and keep on moving, right? We just got to fire, keep on going. Yep. All right, so here we go. Start recording, record. This is recording, so hopefully it does. All right, so on page 52 of the mill, if you don't have it opened up, open it up on your personal computer. So we're gonna go to Haas productivity, and it's gonna be the one in the middle. It has to say basic up here on the top left. Basic Haas VF series. That's how we know we have the right one. Are we there?
There.
Okay. So on this page 52, all right, guys, we're supposed to know this information already from Basic Machine Shop, correct? Tapping, our feed rate equals our revolutions, RPM, divided by our TPI, correct? So that's our feed rate. So we got to figure out what our RPMs first, correct? And then we got to figure out a TPI. How do we figure out a TPI? Oh, how do we figure out TPI? Man, I can't see you, so I can't call on you or pick on you.
Should be on the print.
Okay, hold on. You're confusing yourselves. All right, so if we got 8 TPI, correct? 8 threads per inch, 1 divided by 8. All right, that would give you your TPI. So the RPMs divided by your TPI. Our speeds and feeds, right? So our SFM is our surface feet per minute. So that depends on what material we have, correct? Are we dealing with stainless steel? Are we dealing with titanium? And then what type of insert are we using, or what type of end mill? Are we using a carbide end mill? Are we using a high-speed steel, correct? So we figure out our surface feet per minute. So our surface feet per minute, right here would say if it's 0.262 times your cutter diameter times your RPMs. But that's for SFM. So if we have our SFM, though, figure out our RPM, it's the same formula as we learned from basic. 3.82 stays as a constant, correct? 3.82 times your surface feet per minute divided by your cutter diameter. So if we're facing on that Haas, it's 3 inches, correct? Because we have a 3-inch face mill, right? So 3.82 times surface feet per minute, like we said, our surface feet per minute all depends on what material we're cutting and what inserts we're using, for example, of the face mill, and then divided by 3. If we are using our end mill, 3.82 times surface feet per minute. What matters now? The material, and is that end mill carbide or is it high-speed steel? Obviously, if it's high-speed steel, it's going to have a lower number value because high-speed steel is not as strong as carbide, correct? So we divide that by cutter diameter. In our case, we have that 1/2 inch end mill, right? So divided by 0.5. We tracking? So
Yes, sir.
all this is just our formulas. That's how we figure out our RPM, our feed rate, or like a regular end mill. We have our feed. We got our feed from up here, right? We got our RPM from up here. So it's feed per tooth divided by the teeth on there. So if it's a 3 flute, you're gonna have 3 times your RPM. And that's all it is. That's a little bit of review of what we had on basic. So this is the feed per tooth. So it's gonna say like feed per tooth 0.003, 0.002, those type of numbers, right? That's what you're gonna get on the identification of the tool, divided by the tooth, So if I'm using a face mill, I have 8 teeth on there, right? Because I have 8 inserts. That you divide it amongst each other, then you multiply it times your RPM that you got up here, correct? And then that's how you figure out your feed. All right, drilling and tapping and boring hand cycles. This is basically just explaining how hand cycles helps you produce less G code than what you would line by line. Does that make sense? So for example, if I wanted to peck, and just look at my mouse real quick. If I came over here and started pecking down, right? If I'm doing peck means you go in and then you come back out. You go in and you come back out. What are some of the reasons do you guys think that you want to use pecking?
Your harder metals.
To remove some chips, because why? While you're drilling and the chips stay down there, those excess chips create what? Friction. That friction creates what? Heat, correct? Yeah. Yeah. If you're not using coolant, or if your coolant isn't strong enough and you're going to town at it, you could weld your end mill to your actual part, right? So pecking allows the drill to come out of the hole, so coolant goes in there, and then the shavings pushes the shavings out, but it also cools the hole while the drill is coming out also. Plus, with your drill coming back up, it doesn't have as much friction. It has like a little pause through the friction. Does that make sense? So it's not only that too, but if you just drill down, you continue drilling down and drilling down and drilling down, sometimes what happens with all that pressure, your drill ends up walking. Does that make sense? So with the drill, it goes down, it goes up, it goes down, it goes up, it goes down, it goes up. So it doesn't really bend the drill that much. So it has less of a risk to walk on you. So that's what picking means. So now this is saying, hey, we were smart enough to create something that's called a pecking can cycle. So instead of you programming Z minus 0.1, Z positive 0.1, Z minus 0.2, Z positive 2, Z minus 0.3, Z positive 1, Z minus 0.4, Z positive 1, Z minus 0.5, Z positive. You guys get what I'm saying? That would take so many lines. That's what it's saying right here. It would take 60 lines of code. If you only had 20 pecks. So if we're doing a big massive part that's long, and that hole is 5 inches deep, how long would that program be? Pretty long, right? So we're gonna learn what can cycles does. And we're gonna understand the value of L also. So can cycles. I could read this and you guys could be like, what? Did you just read? Or I could just explain it to you, right? So there are 5 operations, positioning of X and Y. We know what that is, X and Y plane. Rapid traverse, R. So R means after you drill, you come back up to your R plane. So you rapid back up to your clearance. Most cases, it's 100 thousandths. So you drill, you clearance back up to 100 thousandths, correct? So then we're gonna drill, tap a bore, operation on the bottom of the hole, and then the R is gonna retract to that plane again. Let me see. All right, so we're still working on a G17 X and Y plane. A G80 will cancel your cutter comp. We're not gonna go over G80, G98, or G99 really, because it's just gonna confuse you a little bit more. So these are your CAN cycles used on the VF series of the mill. We have a G73, G74, G76, G77, G81, G82, G83, G84, G85, G86, G87, G88, and G89, right? So if we look over here, here's what it actually does. A G73 is a high-speed pecking drill. A G74 is a left-handed tap, right? G76 is fine boring. G77 is back boring. G81 is spot drilling. G82 is counter boring. G83 peg drilling. G84 tapping cycle. G85 boring. All of these say boring, but some of these boring, they bore down and they stop and then they wrap it up. Or they start at the bottom and then they work their way up, right? That's why we have so many boring cycles. Now, we're just gonna go over the ones that we really use in the shop. The ones that are gonna be your bread and butter. Obviously, we have about, what, 12 or 15 of these, right? But if we spend time going through every single one of them, we're gonna waste a whole day just learning what they do versus how they work. So I'd rather use this time to go over the ones that we're really gonna use out there in the machine shop. All right, so this is important to know also. The L is an incremental motion movement, right? So for example, if I'm doing a circular interpretation and I put Z negative 250 and I put an L count as 2, it's gonna go 250, then 250, right? If a L is 0 on a CAN cycle, then it would not execute on the location. Now, just take this with like an idea of what L does. Later on, we're gonna go over more in depth and we're gonna use L. But for right now, just know that L does an L count, or if you put an L0, it won't execute a hole in that location. So when I'm talking about that, I'm talking about like a bolt hole circle, right? So that's all L is. It's very cool. It's an application that's going to save you a lot of time, a lot of coding, just because you're telling it, hey, after you do this, go ahead and drop an L and do it again and go deeper, instead of you writing code all over again for a deeper depth. Does that make sense? All right, so G80 is to cancel your CAN cycle. In addition to this, G00 or G01 code can also cancel any CAN cycle. So by it saying that, guys, I know a lot of you guys are going to read that and say, well, I just got to put a G00 or G01 in. It's going to cancel it. Yes, it is. But normally, if you use any type of CAN cycle, anything between a G73 to a G89, at the end of your program, you want to have a G80 so that you're telling the computer, hey, I'm canceling this, I'm done. Don't use it anymore, right? This is the way it's used out there in the industry. I know a lot of you guys are reading the book and you're like, well, I could do this because I'm not going to do this and I'm not going to do that. And you're trying to find shortcuts. But the way that I'm teaching you guys is the way you're going to see it out there in the industry. And most of these guys are used to running code like that for years. So if you try to do like those little shortcuts that, yeah, they're meaningful, but not that meaningful, and you try to break the cycle what everybody's been doing for so many years just because you're like, well, this will work, look, and I figured it out on my own and this, that, and that. No, don't waste your time on doing those little things. Waste your time more on focusing how to do it correctly, because we saw our test the way it went, right, yesterday. So the way I'm showing you guys, it works, and it's functional, and it's fast. If there's a faster way to do it, you're only going to shave not even 1 or 2 seconds, but you might confuse yourself even more than what you do helping yourself, right? So the way I'm showing you how to program this layout, please learn it that way. Because like I said, this is the way you're going to use it out there in the real world if you work for a machine shop. All right. So now, as we said before, the R is going to bring you back to your plane, and your Z is going to be your Z depth value, right? So a G80 cancels your can cycle, right? So we're going to start right now with a simple program. Is everybody good? Is everybody tracking?
Yes.
Okay.
Yep.
I know I'm going a little bit fast, guys, but like I said, hopefully we're recording this and you guys could watch it again if you didn't understand something, right? Be writing down. What happened? Yeah, so Corey's recording, guys. So if this doesn't upload, if I say, hey, I'm sorry, I don't know what happened, it didn't upload, just send Corey an email. And Corey, please check your emails or get in touch with somebody that has Corey's number and ask him if he could send you that. You know, pay him through PayPal, Zelle. Pretty sure he takes his OnlyFans pages, whatever, right? So, no, do not put this on YouTube. Okay, so we're gonna go ahead and do the G81 getting can cycle. So this is a straight drilling, guys, and this is no peck at all. Just drills going down and then coming back up. That's it, right? So you could use this this can cycle. It's modal, right? What does modal mean? Modal means once I identify this line, the G81, look down here, guys. All I gotta have to do is put a different point value, and it's gonna continue doing that can cycle. Does that make sense? So let's go into depth with it a little bit more so we better understand this, right? So let's look at our code. We have a T1 MO6, tool change MO6, right? G90, which is absolute, correct? G54, G00, X.3, Y.3. Does that make sense? I'm on top of my first hole right now. I'm right above it, right? I start my spindle at 1200 RPMs, M03. I always have to give it the length of my tool, correct? These drills are different lengths, guys, right? My spot drill is going to be very short, very small. My drill is going to be an average size, so I can have a jobber link drill that's very long, 7 to 8 inches, correct? So giving it my G43 is very important. So that G43 is there, and it always plays with your what? With your H. And your H has to match up what? With the tool number, correct? So by now we have a Z 1 inch, so we're 1 inch above the part. We turn on the coolant. Like I said, just leave it out, or if you are so destined to put it in there, put it in parentheses, guys. Too easy, right? So after that, we're gonna give it our G81, which is our can cycle, correct? For drilling. So what do you guys think my depth's gonna be? Z negative 0.6, correct? Because it says it right there. So if your blueprint says, hey, I need you to make this hole, and it has to be through the part. Well, you know right there is 0.5 as a thickness, right? So we know that the drills have what? A point on them. And it could be different degrees. It could be 90 degrees, 118 degrees, 135 degrees. They make drills in all sorts of angles, correct? So we are going Z negative 0.6 because we're clearing this part. We just can't go to 0.5 or else we're going to leave that little V of material in the bottom, right? We have to go past it. So that's why we're going Z negative 0.6. The R is the retract. So after it does this hole and it goes negative 0.6, it's going to come back up, but it's going to be 100 thousandths above the part. Does that make sense? This feed rate, yeah. No. Well, with R being 0.1, it would go 100 thousandths above the part. Yeah, it just stays on the Z. You're doing that because you're gonna put another point after that. Yeah, 100 thousandths. Yeah, and that's just for clearance. Because if I'm going from here to here, my drill can't be inside that hole. Correct? It needs to come back up. Yeah. Yep. That's all it's doing is retracting. So position of the R plane. That's all it's doing.
So the main purpose of that is because you can't have the same code in the same block, right? So instead of putting another Z, they had to make it an R.
No, well, Z is for your depth.
Right.
R is for like your clearance, your retract.
Right. I was just trying to dumb it down for me because.
No, yeah. So Z is how deep you're gonna go, right?
Right.
But the R, you're gonna start at your R. So you're gonna start 100 thousandths above the part. Then you're gonna start drilling down 600 thousandths into the part, right? After you drill, your Z is gonna come back to 0.1 above the part.
Right. But I'm just saying, why wouldn't they just use a Z.1 to bring it back up?
Because it's gonna be less code and it remembers the R, and this is the way the G81 was formatted.
Okay.
And then plus you're gonna have two Z's on there. What happens on a computer when you have two Z's?
Goes the last one.
You get an alarm, right? It says multiple codes, correct?
All right. And that's what I was kind of getting at is because, all right, I got you.
Yeah. Oh, this one is just to identify the tool length and be an inch above the part. Yeah. Then after that, it's gonna go down to the 0.1 when it starts your can cycle. And we're gonna see this in real life on Monday when we actually execute it, guys. So trust me, it's gonna be a little bit easier once you see it in person. Does that make sense? All right, so we went down to Z negative 0.6, right? We retracted back up 100 thousandths, correct? Now this is what it means by modal. My next line, I just have to put my next hole's points in the coordinate system. That's it. So I have to tell it X 1.2, right? Y 1.2. So and when it gets down here, it's gonna move to that location. And guess what, guys? It's gonna do this again. Does that make sense?
So that G81 line is what's telling when you go down to the next block, the X 1.2, telling it what to do when it gets there.
Yeah, that's what they mean by modal.
Got it.
So instead of you having to write that whole code again in a separate block or anything else, all you have to do is give it the points. Now, it has its pros and it has its cons, right? Pro is if you have multiple holes, all you have to do is put multiple points, and it's gonna drill them to that Z specification. But that's also the con. If you have the same hole and the same drill diameter, but you have different Z depths, it's not going to work because you're only giving it one Z depth here. Does that make sense?
Yeah, because the programming always goes back to the last G code, right?
Well, it comes up back to this one, yes. So your can cycle. So your points, whatever point you put down here, it's going to come back up to this can cycle. Until you tell it, hey, that's it, no more, by giving it a G80. We tracking? Yeah. Let's say there's one here and one here, right? Now, yes and no. So if that were the same drill size, you would want to put a G80 to cancel this one, and then you would want to put another one. Does that make sense? But nine times out of 10, you see, guys, the world that we live in the manufacturing process, luckily the engineers at least understand that point. They're not going to really make a drawing that has different Z depths and the same drill. They would have a different drill size going down to a different depth. Does that make sense? So normally you'd have a whole nother tool number. So you'd have to have a whole nother operation under that operation to fulfill the different holes that you're doing. So one like a basic rule of thumb for the engineers, if they could use the same drill size drill hole or the same screws or the same threads, right? They'd rather use that to make it less complicated. Do we know some complicated individual engineers? Of course we do, right? And if that's the case, then you probably just have to copy and paste this program, right? Copy and paste it and just put another Z depth. And that's it. With your different points on there. Does that make sense? And we know how to copy and paste now too easy, correctly? Correct? Oh, it's not a big deal to copy and paste this once you already have one of these on there. We good? All right. So, like I said, if we had two more holes here that were the same depth and were the same diameter, all I have to do is put those locations. So under N6, I would put X.3, Y 1.2, and it would make that hole. Then under that, I would just have to put X 1.2, Y 0.3, and it would make that hole. That easy, guys. I wouldn't have to give it a Z anymore. I wouldn't have to give it a feed rate. All I have to do is under here, put those points on if I needed to make more holes exactly the same as the ones that I did. So that's the beauty about having a can cycle, right? So here we got a G80, so we're canceling can cycle. We got a G00, so we're rapiding. Z1, so we're rapiding back 1 inch above the part. M09 turns off your coolant. Here we could put a G00, G53, then an M05, G28, G91, Z0 does the same thing, right? 30. Cool. That's it. That's your regular G81 straight drilling. So you guys see how, or you see right here how it says R, start plane, and then your Z starts going down. So this is what your R does. It gives it that start plane. So after it drills, it comes back up, and then it has clearance to go to your next hole. We good? Okay. So a G82, very similar to a G81. but it's called a spot drill hand cycle. So what's the difference between this one and the straight drill? What's one of the things you guys see different? Look at the program. Yeah, but look at the program. What do y'all see different?
G82 code.
Yeah, so obviously, guys,
And a feed rate.
yeah, they're not gonna make two codes that do the same exact thing, right? So the difference between the G81 and the G82 is this P value. You guys see that? Up here, we don't have a P.
Yeah, I see that. P1.5.
Yeah, but down here we have a P. So what does a P do? Well, right here, it explains it, right? The dwell time at the bottom of the hole in seconds, right? So what does that mean? If I'm spot drilling, just imagine on the manual mill, guys. If I'm spot drilling and I'm drilling down a spot drill so I could put a bigger drill in and make a bigger hole afterwards, correct? If I just push down on the Z lever and go down, and as soon as I hit my Z point, I'll pop it right back up. What could happen with that hole? It's gonna leave like a line, right? Because I came off of it abruptly. So the drill wasn't able to turn all the way with the two flutes that it has. So it left a line in one of them, right? So what happens on the side of the walls? It left a line. So what happens when your drill comes in? If it catches that line and it puts it on a slight angle and we're drilling down a hole, it's going to end up walking, correct? So what does a G82 do? It gives you dwell time, so it stays down there a few seconds and it cleans up those walls smoothly. Does that make sense? So that way, when that drill comes in, there is no line, there is no burst, there's nothing on the walls, and it catches straight on the angles that the spot drill made. So the angles of the drill are gonna land right on them also, and that way you have less chance of a risk of your drill walking on you. Does that make sense? Very hard to explain this without you guys being in front of me. All right, so if we look at this, guys, same concept, right? I need my intro, but in my intro, just like we gave it a start position and our G71s and G72 can cycles, this start position right here is gonna be the first hole location, right? So your first hole location starts up here while your Z is still up. Does that make sense? A lot of people think, oh no, well, it's not down here, so it's not gonna, no. Why waste time? V, did you just join right now? Woo. Ah, he left. You guys see that?
Yes, sir. We have a problem with connector.
Huh? Boy, I tell you, man. Hey, text him and tell
Let me
him.
call and I will help you to connect a B.
Huh? What did you say, Josue?
I'll call a B and I will help to connect on the meeting.
Boy, he better go to church this weekend. That's all I gotta say.
He was already there, so he knows how to connect.
Yeah, he came in and left. I think he thought, oh man, maybe if I go on, he's not gonna notice. Hey, somebody text him and tell him to get back on. All right. So we look at this code, guys, right? Learning how to write code, the best way to do it is to understand it, to understand what we're doing when we're writing the code, right? That's the best way. It's not by remembering exactly what letter we put where or anything like that. No, it's understanding the process. That's the best way to understand it. So we have a tool number. Obviously, we need to have a tool number, correct? Then we have an MO6. We need to have a tool change. Obviously, guys, by the time that we get drilling, we've already faced the part minimum, right? So we're not gonna use that 3-inch face mill to drill a hole. If you do, you're drilling a big ass hole, right? You're drilling a 3-inch hole minimum. So that's why we still put those MO6s on. So a T1 MO6, right? So we got our G90. This is the mill, guys. We need to tell it whether it's absolute or incremental, correct? Then we have our G54. We've established our G54 either before or after we run the before or after we wrote the program. But we need to establish our G54 before we run our part. Like I said, for your test, I don't care if you write the program first. I don't care if you touch off X or Y zero first. But as long as you do it before you run the program, you're good. This isn't my way or the highway. No, it's what works, correct? So we have our G90, our G54, our G00. We're coming to the first hole right here. X3, X.3, apologies, Y.3, correct? So right now we're hovering above our first hole. Our Z should still be all the way up. Then we start our spindle at 1200, M03. We make sure the actual computer knows the tool length. So we give it the G43, which always plays with your H, and that H has to match up with your tool number, correct? Then we have a Z that goes down to 1 inch above the part. Obviously, we were under G00 before, right? So it's still going to rapid to this position, correct? So then we had on our coolant, but we're not going to do that ourselves, right? This G82, with the G82, you don't need a G01. Does that make sense? That can cycle tells it that it's going to be a linear a cut. So you don't need to put, obviously, you don't see a G01 here, Z negative, whatever, right? We have a G82. So it's a G82, which is a spot drill can cycle, right? We're going to the depth of 125 thousandths. So if you guys remember from Basic Machine Shop, whenever you had your countersink drill, it looked kind of like going down, then it had a sharp point, then it came up, and then it had an angle on it, right? So you need to make sure that it goes down at least to the angle. If we were in class, I would have drawn this on the board, but we got to do what we work with, right? So that's how we know how deep we're going to go with the spot drill. Now, spot drills come in different sizes. They come in different numbers. Number 1, 2, 3, 4, 5, 6. The higher the number, the bigger the spot drill, right? So in this case, we're going 125 thousandths into the part, so it's Z negative 125. Then we have our p-value, right? So that p-value is going to leave it down there for a second and a half. Cleaning up the walls, then it's going to go back up to R.1. Then your feed rate is 10 thousandths. So after it does that, it's going to go to your next hole on X 1.2, Y 1.2, and it's going to repeat this process again because it's modal, correct? After that, you're going to give it a G80, cancel the G82, G00, Z1 inch, turn off your coolant, G53, G00, Z0, M5, and that's it. Too easy?
Say that now.
So this, we gotta think realistically, right? So first you're gonna do your facing. If you have nothing else on that part but holes, then you're gonna do a G82, right? You're gonna do a spot drill first. Then you would do like a G81 with your drill. Does that make sense? So we could copy and paste this all day long, but as we mentioned yesterday, if I copy and paste this, go through the whole program again, understand what numbers you got to change, right? So if I made this first and then I wanted to come back and just drill, right? Most likely, if I copy this program, so it could be the next operation. For my next operation, I'm going to have to change my tool number, right? I'm going to have to change the T. This X3, Y3 is going to stay the same because I just spot drilled those holes. So now I'm going to come in with the drill and drill those holes, right? So that's going to remain the same. If I work out my math, I figure out my speed, right? I need my G43. I need to change that H to whatever tool number I have in the machine now. If it's tool number 2, fine. That H needs to match that T though, so that would be T2, H2. I still need to come an inch above the part. And now this G82, I'm going to change that to a G81, correct? And then I will change this Z depth value to whatever I'm drilling at. So let's just say in this case, I was drilling to a Z negative 0.6, right? The P, well, we have a P value here, but we don't have one up here, right? So what would I do? I would just delete the P. And then the R stays the same, feed rate stays the same, next point stays the same. I still cancel my can cycle, so everything else remains the same. Does that make sense? Yeah. Because 9 times out of 10, like this one has, sometimes you don't need a dwell. If you don't need a dwell, why are you going to dwell? You get what I'm saying? What? So normally, if you got a through hole, there is no dwelling because you went through the part, right? So if you're drilling, but you're just drilling a hole to tap, so you're not going to tap all the way to that point because that drill is going to go past where your threads need to be at, right? So there's no reason to dwell on the bottom of a hole of a tap. Now, this is just for like, let's say, for example, spot drilling. For spot drilling, you want to, because you're going to make that little spot for the drill to go into. Does that make sense? No, because even if I'm drilling, if I'm drilling a blind hole and I'm threading it afterwards, right, and it's a blind, I don't need a dwell for a spot drill because the drill goes past where your threads are going to be. So that screw is, yeah, it's just if you need to clean up the lines, you're going to use a G82. Think about it that way. So for like another example is you could use this G82 for counterbores and countersinks, right? So if you have an end mill and you're doing a counterbore and you wanted to sit there and clean up, you'd use a G82, correct? So we just need to know what application we're doing and which can cycle to involve it in. That's all it is, guys. It just needs to make sense. Not like the Army anymore. Here, if it makes sense, go with it. All right? We're good? Okay. A G83. Now, this is the one that's most commonly used at a shop because a lot of times we're drilling quite a ways down, even if the hole isn't a big diameter, right? Even if it's a small drill, even if it's a quarter, sometimes it's better to peck because you don't want to break that drill. Because what happens when you break that drill? You got to replace it, right? And then hopefully you didn't break it in the hole. Because if you broke it inside the material, now you got some other stuff to worry about, right? So a G83 is used to save the tool life, but not only that, but to save your company time and eliminating the risk chance of your drill breaking inside the part, right? So your G83 is kind of like your bread and butter when it comes to drilling. Every shop that I've worked at, we've always used the G83 for one application or another. Have we used a G81? Yes. Have we used a G82? Yes. But a lot of percent of the time, you're going to be using a G83, right? So the F is still your feed rate, correct? Your I is the optional size for your first cutting depth. Your J is the optional amount to reduce cutting depth per pass. Your K is the optimal minimum depth cut. The Q is a cut in value and it's always incremental. R is the position of the R plane. X, Y, and Z, you guys already know what that is, right? So, most of the time, you're not going to use I, J, or K. You're just going to use Q. But they want you to know that I, J, and K are available, right? So, let's say I was cutting some type of material that it's very gummy. So, when I first drill, I need to get under it. I can't just, skim 10,000s because then it's going to just gum up the material and it's not going to make my hole a perfect circle, right? So I might want to use I and go into the part more than the rest of it. Does that make sense? I'd want to establish that circle first. So I'm going in 200,000 on my first one. Then after that, I'm only going to go 100,000, right? So that's what J does. J is the amount of oh no, I'm sorry. So J, it reduces your cutting depth per each pass. Let's say you were doing a really long hole, but you wanted to start taking off 500,000. Then when it comes back up, you want to take off 400,000. Then it comes back up and you want to take off 300,000, right? So the optimal amount reduced by cutting pass would be 100,000 in that case, or you can make it 50,000. K is the minimum depth of cut. So if you're telling it, hey, take off 100,000 per pass, and you started at 500,000, you could tell it, hey, but after you hit at 200,000, don't go any less than that. Continue at 200,000. Does that make sense? There's rare cases that I've used that in. It was more like, hey, this material keeps on breaking on drills. We don't know what's going on. If we take the same depth amount of cut, the deeper we go in, the same depth of cut that we're doing, it breaks the drill. Okay, so after you hit 2 inches of drilling, then decrease your depth value after that. So that's when I would use like a J, right? So, hey, I'm not taking off half an inch anymore per pass. I'm taking off 300,000 or 200,000, right? Because after it reaches halfway through the part, then it starts breaking my drill if I'm still taking out that depth amount. Does that make sense? So that's how you would reduce it. After that 1 inch, don't go as deep, but continue going. That's what the I, J, and K are really for, right? But a lot of times, we're going to use a Q. So let's look at our program. Same thing as the other one, guys. Same intro, right? So we have our tool number, tool change, MO6, G90, absolute, G54, G00, X.3, Y.3. I'm coming to the first. I'm hovering right above the first hole, correct? Spindle speed 1200, M03. I turned on my spindle, right? G43, H1. I told it my length. Z, 1 inch above the part. MOH and undercoolant. G83. So this is your pecking can cycle, right? Your Z is always going to be your depth. How deep do you want to go? What does the blueprint say? Is it a blind hole and it says only going 250 thousandths, right? Does it say through like this one? So if it's 0.5, we're compensating for the point of the drill. So we're going to go Z negative 0.6, correct? So we're drilling through the part, right? Our Q, well, we just established what Q was. So it's good. If we Q 0.1, it's going to go in 100,000 every time it goes in, right? Your depth. Pretty much your Q is like your depth of cut, right? R 0.1. So what is this saying? With your Q, you're going to go in 100 thousandths, come back up to 100 thousandths. Next, you're going to go in 200 thousandths, come back up 100 thousandths. Next is going to drop to 300 thousandths, come back up 100 thousandths. Next is going to drop to 400 thousandths, come back up to 100 thousandths. Then it's going to drop to 500 thousandths, come back up to 100 thousandths. Then it's going to drop to 600 thousandths, then it's going to come back up to 100 thousandths. Does that make sense, guys? So just imagine everything I just said right now was a line. So you're going in 100 thousandths, Z minus 0.1. You're coming back up 100 thousandths, G00, Z 0.1. You're coming back in 100 thousandths, G01, Z negative 0.2. Then you're going to come back up to 100 thousandths, G00, Z 0.1. Then you're going to go back in, G01, Z negative 0.3. Does that make sense? How much line of code would I have versus just having this? 9 lines, guys. 9. And I could drill up to however long that damn drill is. I could drill freaking, if I had that long of a drill, I could drill 3 feet if I wanted to with this line of code. Does that make sense?
Got
Are
it.
we tracking? I mean, you guys gotta understand how cool this is. It saves you. Okay. Because I'm like, man, if everybody's asking me, I'm gonna go open up a beer then. This is my weekend already.
We're all sleeping.
Huh? I
What?
know sleeping. I know V's just logged on and he's like, I'm here. V, let me hear your voice, V.
Yo,
What happened, V? I don't want to answer you. I'll just be quiet and talk to you on Monday. Hopefully you'll forget. All right. So we understand though, a G83 the can cycles, right? Just 9 lines, guys. 9. And if you had more holes, all you had to do is input the points. That's it. If this was 30 inches that you were drilling, Z negative 30. That's all you had to do. So this is a big, big time saver, right? So this is an exercise. I want to leave this for homework for you guys. Page 60 and 61. Y'all want me to print it out for you? So make sure you do this. If you have Adobe Reader, download both of these pages and just put it on there. If you got a printer, just print it out. If you don't have a printer, bring out a piece of paper, go to old school, write down all those G codes and everything, and write the code down, right? So your next test, your final test, you're still gonna have a facing operation, you're still gonna have a profile operation, and now you're gonna have drilled holes in there also. So the more we practice this, the better we're gonna be, right? Here go all your can cycles, guys. I mean, they just laid it out for you. This obviously you know is your safety line, right? What are these gonna be? G00, G53, Z0, right? We're making sure we're on the top. Over here it says T. T what? Well, right here it says tool number 1. It's a 1/2-inch diameter, 90-degree spot drill, correct? It's giving me my surface feed, right? It's giving me my feed per revolution, correct? Why do I need that information? Well, we go up to what we learned on the first page, that little review that we did. Look at that, right? All I have to do is plug in those numbers, correct? Plug in those numbers, guys. That's all you have to do. Make sure that you understand your feeds and your speeds. I don't want to hear, oh, well, I just put 30 for feed. That's a good feed, right? You know what look you're going to get if you ask me that question. You already know, right? This exercise, you guys have the whole weekend to work on this. So this should be filled out. Right, V?
Yes, sir.
There you go, right? I need this filled out. Why? Because you're going to understand this better. And like I said, hopefully this is recording. So if you guys are like, man, I can't remember how we got this number or what we went through, go back to the recording, right? If I can't upload it, I'll send an email. Hey, get with Corey, see if he could send you the actual the recording that he did. And look at this, guys. I know a lot of you guys had this question, right? How do you make threads on the mill? Tapping, correct? What's a G84? Tapping can cycle, tapping right-handed threads. What's a G74? Tapping left-handed threads. Look at this code. Doesn't it look exactly what we just did right now? Right? We have our tool number. We have our tool change, correct? Who's that? About a mute.
Joseph.
Yo,
Si quema acá. All right. We have
what's
our
much
tool number.
today?
Huh?
No quema today.
We have our tool number. We have our MO6, G90, G54, G00, X.3, Y.3. Notice, guys, that if we're going to use a G84 or a G74, we don't need to give it a direction on M03. This is the only time you don't have to. Do this while you're doing a facing or a profiling, you're breaking your tool. Why? Because your spindle's not spinning, right? But you're going to give it your RPM. And we figured out RPM by our formula, correct? So now, by it reading this G84 or this G74, it's going to know which direction to turn. Does that make sense? That's why you don't need an M03 here. Because obviously a G84 is going to turn clockwise and the G74 is going to turn counterclockwise. That's why it says right here, you don't need to turn the spindle on. We tracking?
Isn't that also because it's got to back out as well, so it's going to spin in the opposite direction?
Yeah, but it reads that by the code, the G84 and G74. When it goes in clockwise, it starts clockwise, and then it retracts it. But if you turn it on the Haas, it'll still cancel it, and it'll still do your G84. Now, can I say that for every machine, even the older ones? No, I can't. So I would just follow this rule by not turning it on. Does that make sense? So after that, we have our tool length. 243, H01, Z1. We already know what this does, guys, right? We're setting the tool length. There's your little tap, correct? G84, Z minus 0.85. They went a little bit further this time. Why? Because these first little 3 or 4 lead threads have 4 threads. So they want to make sure that this part is actually full. And it all depends what type of tapping tool you get, right? Do you get the pointed ones? Do you get the flat ones? It all depends what style you get. Retract, 0.1. Feed rate, 60. And here it is. Your RPMs, your speed, divided by your TPI. Correct?
So in the top, it says Z position at the bottom of the hole. So Z will always be the depth of the hole.
Yeah, so you're going down 850 thousandths. So right there, you're gonna be 1 inch above the part, right? Then it's gonna read that R.1. So it's gonna come right here, 100 thousandths on top of the part. Then it's gonna read that Z negative 0.85, and that it's gonna read that G84. So it's not gonna, the spindle's not even on yet. Here, it's gonna turn on, go down 850, reverse, back up to 0.1. That's what it's doing right there. Then, since you have another hole location here, it's gonna come over here to this location. And it's gonna do the same thing over again. So after that, of course, we have to cancel our can cycle, correct? So we have a G80, G00, Z positive 1, M09 turns off for coolant, G00, G53, Z0, G00, G53, Y0, M30. How many of you guys thought threading was going to be harder than this on the mill? No? I thought it was going to be easier? Okay, cool.
Mm-hmm.
All right, well, we'll do this because that is better explained in person. But like I said earlier, guys, if you guys went over that in basic, look how much time we have left. And we're already crunched for time. It kind of irks, like, you know, the instructors when we have to go back and learn a lesson that we should have learned already. You get what I'm saying? Because now we're wasting more time on that. I'm ready to jump on the lathe now and teach you guys how to drill holes on the lathe. If I have to go back to explaining this, something that you guys should already know, something that you guys should be tested on already, takes up a lot more time. Does that make sense? Yeah, so do this. I know in your basic book, there's a page that has those formulas, right? I think I left my book in the office, so I don't have it with me right now. But there's a page for the mill that has the fees, that has the speeds, that has everything on it, right? Make that part of your homework too, so you can figure out your numbers, right? And then when we show up in class, we'll do it together. Because we have a perfect example too, right? The homework I gave you guys. So you guys have it right here. It gives you your surface fee per minute. That one is questionable because you don't know what type of sometimes the book doesn't have the material that it identifies, right? Or it doesn't identify high-speed steel or carbide, but it's giving it to you right there. It's giving you your feet per revolution right there. Does that make sense? So trust me, open up your basic book, look at those problems, understand it, then substitute these numbers for those numbers, and you're gonna get it. Does that make sense? No, the one you took in basic machine shop, that precision book, the precise book, there's a page on there. Yeah, the big blue one, there's a page on the mill, and there's examples there. And it shows you exactly how to get it, and it breaks down the problems like you're saying right now. Because that's what I'm gonna do. I'm gonna take that book, and then we're gonna go through a problem in the book. Then we're gonna reference these numbers. You guys could do it yourselves. I mean, it's not that hard. I get what you're saying. I want to double check my answers and everything, but I could be teaching you how to drill on the lathe right now. Which how many of you guys have done yet? None, right? And that's one of the ops that we need to go through. And that's one of the ops I want to go through before we leave because it's a G83. Same thing that we went through here, so we can reference it, right? That way it's not like, oh, I'm gonna teach you grooves and then OD threads, then I'm gonna teach you how to drill. No, I want to do it on the same day because your mind's already thinking right now what a G83 is, how a G83 works. So if we go over the lathe side, you're gonna understand it better today than if we wait until Monday to go over it. Does that make sense? All right, so for right now, guys, everything else is the boring bar. Really, we don't bore too much on the lathe. There's a video that I might look up and then show you guys. So, yeah, my fault, my fault. Yeah, I meant the mill. There's a video on that shows you how to bore on the mill. So what it is it's a tool that comes down and sticks out, and then that's your boring bar. But on top of the tool, you have like a little measurement dial that you increase it or decrease it so you can get the exact hole size that you want. So if you look at the program, I'm near the same thing, right? You're just boring down there, and that precise hole, it's all going to depend on how much you open up the dial or close that dial. I'm going to try to find that program on YouTube, and I'm going to send it to you. If you guys get to it, do number 64 also if y'all want more training. If y'all finish the other one and y'all feel comfortable with it, do that one. A lot of these other pecking drills and everything like that, same concept, just different codes, right? And for the mill, I think we're gonna stop there because that's about an hour and a half of material. This is gonna be easy to understand once we understand the holes, right? It's gonna be too easy because we already have an understanding of the holes, but I would go ahead and let you know what the L does afterwards, like the loops. And trust me, once you guys know what the loops are, it's gonna be a lot faster and a lot easier to understand it. Hold on, somebody's in my front yard. But I want to show you guys the actual drilling can cycles on the mill in person before we go over the loops, because the loops is just what we learn, but pretty much a little bit more advanced. So I want you guys to see this in person, the basics down first, and then we'll learn the more advanced parts. All right. So let's go into the lathe.